It may not look like it, but we're professionals. Do us a favor.
Don't try this at home. Whoa!
On this high-flying episode of Mythbusters.
One word for this. What?
The whole team tackles one massive myth.
Everything in your mind is saying, don't do it.
Testing the tale of a spectacular mid-air mishap pushes everyone to the limit.
This whole story is just totally absurd.
They'll need luck.
For science.
Courage.
This is the best data ever!
And some serious science.
That's perfect.
To tackle the myth of the man who fell to Earth,
Grant, take it away.
struck a seesaw, and launched a legend. Who are the Mythbusters? Adam Savage.
True and fancy-free.
And Jamie Heineman.
You just need a little extra lubrication.
Between them, more than 30 years of special effects experience.
Oh, I'm taking Big Jamie out for a walk.
Joining them, Tori Belleci, Grant Imahara,
Let's go, come on! I'm gonna be rich!
and Carrie Byron.
That was a rush.
They don't just tell the myths, they put them to the test.
A little old for dolls, aren't we?
This is not a doll. This is a demonstration model for the next story we got to do, which comes right from the fan site.
Okay, tell me more.
I'm a skydiver, right? And I'm falling through the air. And my parachute has utterly failed. Looking desperately down at the ground for something to break my fall, I spy a children's playground and a seesaw with a little girl at the other end. Not worrying about her, I aim for this end of the seesaw, go straight upright at the last second. I hit the seesaw and catapult that poor little girl up to the top of the 7-story building where amazingly she lands safely.
Wow. Sounds almost too good to be true.
I thought the same thing.
Improbable, yes, but impossible? Parachutes do sometimes fail to open. If he's jumping over a town or city, it's feasible he could drop over a playground. Common sense and basic physics tells us that if he hits the seesaw, that lonely little girl is going somewhere. But 7 stories high, and she lives? Well, don't knock it till you've tried it.
Jamie, I don't know about you, but I feel like we could just go for this one.
Sure, we can do it right outside. All we need is a regulation seesaw.
And a correctly weighted little girl.
And a skydiver.
Terrific. Let's do it. When I was a kid, seesaws were long wooden planks, and that's what we started looking for, but it turns out no one makes those anymore. Now seesaws are made out of steel, and there are as many designs as there seem to be playgrounds. So we have chosen a mid-range, middle-of-the-road, simple steel seesaw, and that's what I'm about to build.
For Adam, building a 2-kid plaything is a one-man job. Inside 30 minutes, he welds a central pivot from 2-inch pipes and a couple of elbow joints.
The bench itself is just a 10-foot slab of hollow steel. Now I've just got to attach one to the other.
But here's the problem. To hit terminal velocity, the unlucky skydiver would have to fall from at least 600 feet.
So to get around that problem, at least for this first test, what I'm doing is trading altitude for weight. When I fill these barrels with water, they'll be much heavier than a man, so we can then drop them from a much lower height and get a more or less guaranteed hit. And the impact force should be exactly the same.
That's the theory, and they can't wait to put it into practice. So they've picked a drop zone that's real close to home, the parking lot behind M5.
And that's just getting welded down to the plate?
Yeah.
Okay.
It's a stunt that will scare the neighbors. Given the massive forces at play, only a lunatic would choose this moment to trial a new technology.
This quick release, which holds up to 10,000 pounds, is going to be the mechanism by which we drop our weight on the seesaw. And normally we've used it in a pull-on-a-wire mode. Now it's got an automatic cylinder release, which, when we connect a battery from our viewing site and I say, connect the battery, it's going to drop the weight right on our seesaw.
Now for the checklist. They've got the crane, they've got the weight, and Adam's built a teeter-totter that both sees and saws.
Okay, so it is, in fact, a seesaw.
It is, in fact, a seesaw.
I want one of these in my office.
All we need now is a full-scale victim, and this one is almost too cute to catapult. Almost.
So shall we name her Ariel?
Nice call, JD, but it's best not to get too attached to your missiles.
All Our little girl over here is supposed to be an average 6-year-old, and so we've made her weigh 50 pounds. Now, if the physics in this story are correct, the water barrels, when they hit this end of the seesaw, are going to launch her straight up about 70 feet or 7 stories.
I calculated filling the barrels with 1,150 pounds of water and then dropping them from 75 feet should exactly match the skydiver's free-fall impact force of 85,000 foot-pounds. So I'm going to pull the safety, but you know what? I don't want to be anywhere on this lot when we drop this thing.
I was thinking we should be up over there.
I was thinking the same thing.
So with the elements in place, Adam and Janie head for the high ground.
Right now, I describe the situation as mayhem in potentia. Soon we'll have actual mayhem.
And that actual mayhem is now just moments away.
All right, here we go. Skydiver Seesaw in 3, 2, 1.
Oh, darn, the seesaw broke. It just kind of like folded in half.
The bench is buckled, but the full extent of this disaster is best assessed from ground level.
It not only crushed it right at the pivot point, but it also crushed it right at the end here. So, you know, that's a heck of a lot of force.
A lot more than we considered. We're going to have to rethink this thing.
Yeah, even if this was a solid bar of steel, I don't think it would have taken it.
Yeah. I swear, this is the best part of the job, reviewing the high-speed footage.
I want to see if she even comes off the ground.
I think she does. I saw her flip a couple of times.
Yeah.
Little Ariel launched at exactly 23 miles per hour and then flew 20 feet high.
Come back.
That's barely 2 stories, way short of the mythical 7. But with all the substitutions, this test was always more likely to be an indication than an indictment.
I can't help but feel this nagging feeling in my head that there's a big difference between 1,000 pounds of water in steel cans and a soft 100 and some odd pound skydiver falling at terminal velocity.
Now we need to figure out, if we're going to make this work, how to get all of that energy over there to come over here to the little girl without wasting itself on breaking things in the process.
In short, the fact that a home-built seesaw cracked under the weight of 3 sharp-edged barrels doesn't prove or disprove the myth. And with the help of Tori, Grant, and Carrie, things will get better. Still to come, Janie goes high-tech on the high jump.
That's perfect.
Awesome.
But next, Grant and Tori risk their lives to legitimize the legend. The common playground seesaw is about as safe or as dangerous as you want to make it. But could it really toss a girl on top of a 7-story building? Well, it flipped an elephant, right?
Dude, there is a lot to do in this myth.
Yeah, there is, but I'm ahead of you. Reinforcements should be arriving now.
What do you need?
Okay, you know the seesaw myth that we're working on?
Yeah.
We need a way, first, to calculate the terminal velocity of our skydiver. Specifically in the myth, it's stated that he is wearing a camera suit. That's a specific kind of skydiving suit. We need to know how fast he's going.
Okay, cool. What else?
Well, we need to have a delivery system for the skydiver to put him on target at terminal velocity.
Giant crane? I don't know. We'll figure it out.
All right, we'll see you later.
Great. Always have to be the hero.
So on the very next misty morning, the team arrives at Skydance Skydiving to see just how slowly a man can fall in a camera suit. Grant's our designated diver, and Nick Armstrong's here to point him in the right direction. Down.
So this is the camera suit.
Yes, it is.
Can you tell us a little bit about it?
Sure. It's different from most of our skydiving suits in that it's built specifically for videographers.
The key design difference is a wing-like flap from the elbows to the hips that should give added air resistance.
So you can get a lot slower with one of these suits on.
Absolutely.
Grant's not licensed to go solo, so he's doing a tandem jump. Nick's wearing the camera suit and a fancy Alti-Tracker wrist computer to log the details of his descent.
He and Grant are both going to go up. They're both going to jump at the same time. And when Grant gives Nick the signal, he's going to spread out as far as possible to see if he can slow down his descent.
And when he gets off the plane, I'm going to take that, download it into a computer, and we'll have a graph that'll tell us all the speeds.
Now, after Nick is done with the spread eagle position, then he's going to try flapping his wings. Is flapping your wings going to make you slow down more? I don't know. Maybe it'll take your mind off the fact that you're falling without a parachute.
For a veteran skydiver, flapping your wings sounds a touch undignified, but it's worth a shot. When the plane hits 2 miles high, the passengers push off. Once the guys get situated, Nick initiates part 1 of the test, spreading those tiny wings. The result is just as predicted. Relative to Grant, he does seem to reduce his speed. A few seconds later, Nick tries flapping like a giant pelican to see if that slows him down. Team Imahara makes a perfect 4-point landing.
Nicely done.
You're safe and sound.
You made it!
And our eye in the sky has a fair idea of what worked and what didn't.
So he opened up his arms and he was gone, just like that.
So when he reset and tried to start flapping, how'd that go?
Yeah, I saw him come back down and they started flapping his arms and he was just falling at the same speed I was.
To confirm Grant's account, Carrie downloads the data from Nick's wrist computer. And the graph couldn't be more clear.
When Nick opened up his camera suit and went completely spread out so he had the most surface area, he slowed down to about 114 miles an hour. But over here, this is where he started flapping his wings like a cartoon to see if he could slow down, you know, Goofy style. That didn't seem to work too well.
So 114 miles per hour looks like the speed to aim for. But Grant's remembered a crucial part of the story they've overlooked. So Tori needs to suit up.
We need to send Nick up again, because the myth specifically said that the skydiver tried to land on his feet. In other words, he fell spread-eagled like the last test, but then at the last second tried to land the jump. And I'm guessing that even if the guy only went perpendicular for a second or two, it could significantly change the speed at which he hit the seesaw.
They all assume the standard frog position. It takes 10 full seconds at least 600 feet of free fall to reach terminal velocity. Then Nick tries going vertical. It's harder than it looks. A few seconds later, he tries again. Hopefully, Nick stayed upright long enough for the computer to register any change in velocity.
Then, at the last second, he tries to land on his feet. He kind of closes up into a smaller position, and his speed shoots up a little bit. But since it's only 1 second, he gets to about 122 miles an hour. Now, that is the important number right there, because that's going to be the final speed at which he hits the seesaw.
After the break,
let's bump this up.
The super seesaw takes shape.
3, 2.
While Adam discovers a small-scale miracle.
Wow! That tells me there might really be something to this.
For just the second time in Mythbusters history, the whole team has pulled together to test one fantastic fable, the skydiver who hit a seesaw and sent a little girl 7 stories high. If that's not too hard to swallow, the myth says she survived the adventure. But that car park catastrophe still haunts Adam.
It's not looking good for this myth, man. I mean, if our regulation seesaw made of steel can't come close to handling the forces, can't transfer the energy from the skydiver to the little girl, then this thing's busted before we've seen anything fly.
Yeah, the forces involved are really enormous, but there's nothing stopping us from improving on that design, like making one that's indestructible, a super seesaw.
We can build the mother of all seesaws. I love it.
And then if it holds together, the girl might just fly.
She might.
And Jamie has some grand plans. It may not be the best seesaw ever. Who knows what NASA has locked away. But he's aiming high.
We want to exactly be done with delivering the load from the incoming projectile right before it hits the ground.
But why scribble when you've got the software to design and test the concept?
We're using SolidWorks software here, which I've had for a while, but I've never really been able to use it to its full potential. The beauty of something like this is that it really allows me to push the limits of the material in the design, because it doesn't matter if the design breaks in the computer. I'll just pull up another one, change it a little bit, and try again. And that way, by the time I get around to building the real thing, I already know it's going to work.
Jamie's decided to build his bench in 2 parts, both hinged on a pivot.
Where's that put us as far as our yield strength?
The big picture here is to maximize the energy transfer from the falling man to the girl and to keep the seesaw intact.
So I started thinking about what do I know that is really massively strong and lightweight. And so what I came up with was a construction crane like this toy here. Instead of relying on something to not bend, they put a cable across the top of it so the load that's being experienced is on that cable. And instead of a bending force on this spar structure here, you've got a compressive load. It's hard to see here, but the load is this way. And so you end up with something that's able to build whole buildings, and yet there's really not a whole lot there.
While Jamie thinks big, Adam goes small scale to get some idea of what to look for when they try this again at full force.
Building a toy teeter-totter is easy peasy, and I don't know, kind of wholesome, you know? This is our little girl, as creepy as she looks, and this is our skydiver, as much as it looks like a round ball. They are the equivalent weight relationship of our real skydiver and our real girl, about 3.5 to 1. What I want to investigate with this is what happens to her when the skydiver hits the seesaw? The seesaw doesn't break. Where does she go? What is her trajectory, and what can I predict about her trajectory?
So Adam starts test number 1 from 10 feet up on the scissor lift. A plumb line indicates the perfect drop point, and it's bums away.
3, 2, 1. Oh, God, that's one of the best high-speed shots ever. I dropped the weight from about 10 feet up, and she smacked into that lamp at a pretty high speed, which means she's going higher in the air than the lead weight is starting from. That tells me there might really be something to this.
So Adam installs a scale that measures the drop height at 6-inch intervals.
All right, 30 inches.
He starts out from just 30 inches.
3, 2, 1. Dropping from 36 inches. For such a simple test, this one is giving me tons of data. And good data. 42 inches. Number 1, I think she might actually make it to the roof of that 7-story building or higher. There we go with 48. Secondly, I'm noticing her flight characteristics. She is pretty much staying in line with this seesaw. Wow! Either landing where she took off from or landing around the center of the seesaw. That gives me a really good bead on where we can all safely be when we're watching this thing happen in full scale. When I dropped the weight from 54 inches, she flew 8 feet into the air.
Wow.
I'm looking at this, I think she might actually make it to the top of the 7-story building.
But a full-scale girl won't hit those dizzy heights without Jamie's super seesaw. They've got the parts, and now they have to put it together.
Obviously, we like the complex engineering challenges. Lead balloon. Shredded plane. Yeah! Ping pong rescue. This is the first time we've ever resorted to computer simulations for calculating the huge amounts of energy we're dealing with. When that skydiver hits our seesaw, it has to transfer all of its energy, all of his energy, to the girl. And everything that we've done thus far says that this will do that. I'll believe it when I see it.
This is one of 2 trusses that will make the seesaw, and even without welds on it, it's really strong. We're not only using a different material, in this case we're using chromoly steel, we're using a different configuration of it as well. The way these joints kind of grab all of the other members, it's going to be really, really sturdy once we get it all welded.
This thing that looks like a maximum security birdhouse is in fact the vital fulcrum.
The trusses like this are going to be welded onto here, and this is where the pivoting happens. It's got to be really strong because there's going to be one heck of a lot of weight hitting it.
And if this engineering marvel breaks, the girl, just like the myth, ain't going nowhere. Coming up, Tori and Grant take the plunge to fine-tune the physics.
Yeah! Here we go.
And later, this improbable myth comes to a shattering and surprising conclusion.
Don't try anything you see on the show at home.
We're what you call experts.
In just 2 days, belief in the myth of a skydiver hitting a seesaw and shooting a small girl 70 feet high has waned.
We're gonna have to rethink this thing.
And waxed.
Wow!
Jamie's super seesaw looks promising, but now they need to find a way to accelerate a full-weight dummy to terminal velocity and hit the target.
Okay, so now we know the speed that Buster has to fall to hit the seesaw, just over 120 miles an hour.
Yeah, but there's a problem. We need at least 600 feet to get to that speed.
600 feet? Do you know how hard it's going to be to hit a target dropping Buster from 600 feet?
Yeah, so we need to figure out a way that Buster can fall faster than gravity at a reasonable distance, like 100 feet, and still hit the X.
What about bungee?
Bungee?
Yeah, we do like a reverse bungee where we attach Buster to one end of the bungee, we anchor the other end, then we stretch him up and release him. It hits the target every time.
Fresh from skydiving school, Grant and Tori head for the hills to try another extreme sport. Again, it's all in the name of scary science.
You know, we got close on board a slingshot, but we've never actually used bungee in an experiment.
Yeah, I mean, it's a good idea, but is it going to get our skydiver up to 122 miles an hour?
Well, you know, there's only one way to find out.
We're going to have to jump, huh?
Yep.
It's that reverse thrust they're looking for.
1, 2, you.
Tori's the first to take the plunge.
Don't worry, buddy. It'll all be over in a few minutes.
I know, that's what I'm worried about.
Remember, go big. You cannot dive too hard or too far.
Oh, man.
Go big.
Oh, man.
Or here's a thought, just go. It sure looks like Tori rebounded faster than he fell. At least he had fun.
Everything in your mind is saying, don't do it. And then once you get over that fear and do it, then there's like this sensation of all your guts going into your mouth. And then you hit the bottom and you bounce up and you do it a couple more times. So it's like it continues.
And while Tori's concerned with the state of his guts, Carrie's about to be up to her elbows in someone else's.
This is going to be my falling parachutist. Now, to make him, we need something that's going to emulate the human body, which is approximately 75% water to 25% solid materials. Now, to do that, we're going to use an alginate. This is used for life casting, taking impressions when you go to the dentist's office. We're going to fill this wetsuit with the wet alginate, and hopefully we are going to have the perfect analog for the human body to fall on our seesaw.
In short, he'll go splat just like a real man. And Carrie's figured the average athletic weight at 171 pounds.
Kind of feels like guts. And yes, I do know what guts feel like. I've been on the show for years.
It's Jamie's fate to carry the load, assuming he can lift it.
Oh, jeez.
They finally do make the scales. Jamie's already weighed in at 180 pounds, so they'll subtract his bulk from the total.
So how much?
It's good. It looks like we only need about another 20 pounds. And I haven't done the feet or the hands yet. So I think we're right in the zone for the body.
Okay, so that was only about what?
150.
Really?
Yeah.
I'm getting old.
Back on the bungee bridge, it's Grant's turn.
For science. This is the best data ever!
Let's hope so. Both Grant and Tori are trying to feel the pulling power of the bungee.
Well, you know, I think this is really going to work. I could really feel the stretch and the acceleration on the way back up.
Yeah, but we're definitely going to have to tweak this in order to get our skydiver to go 122 miles an hour.
Casey, how are you?
The man who might be able to help them out is Casey Dale from Bungee.com.
Rubber bands are rubber bands. We can stretch rubber band for you.
We'll need his best and biggest rubber band, which Casey calls a mongo.
Mongo means a really big cord. New Zealand style cord so that it has more stretch and rapid acceleration.
So you think you'll be able to get it up to 122 miles an hour?
Put enough rubber in, stretch it hard enough? Absolutely.
Meantime, Carrie struggles to dress her man. Then add some personality.
Hey, there you go. Now you have a head better to see me with. Put a parachute on you, drop you out of the sky to your death.
With the frame finished and the parts fitting perfectly,
That's perfect.
It's awesome.
Adam and Jamie rigged the high-strength Spectra rope. Working just like the cables on a crane, this should give us a compression rather than a bending load.
Well, that's just another seesaw.
That's what it is.
In theory, the rope is even stronger than the spars, but no one knows for sure if this amazing structure can withstand the sudden impact. And then there's Ariel. Will she survive? Will she even fly? The big questions and a dozen little ones will all be answered tomorrow. Next up, the boys go heavy metal in a shipyard. and early testing goes totally pear-shaped.
Oh my God! Did you see what happened?
All 5 Mythbusters have joined forces to make or break a bizarre urban legend. The young girl who supposedly survived a 7-story flight from the end of a seesaw. No surprise then that the test venue is a spectacle in itself. Mare Island Naval Shipyard.
Now, the myth states that once the skydiver hit the seesaw, the little girl flew 70 feet up, 7 stories, and landed safely on top of a building. Now, this works out perfectly for us, this location, because the dry dock is 30 feet deep, and that scaffolding right there is 40 feet tall. So when we place it on the side of the dry dock, that is our 7-story building. It's our point of reference.
Adam, Tori, and Grant have arrived a day early to make things right for the big test.
You might be wondering what these giant plates are. Well, we can't weld to the dry dock, we can't drill into it, we basically can't modify the dry dock in any way. But we still need something solid to attach our bungee cord to and to attach the seesaw to. So our solution? Trench plates. Each one of these weighs 7,500 pounds, and we have 2 of them for a total of 15,000 pounds. I think that ought to be solid enough. Whoa.
While Tori welds the plates together, Adam nervously considers his next step.
I want to make sure that my skydiver hits this seesaw square on. So I'm going to run 2 guide wires that will guide him all the way down to hit the seesaw precisely. I've got to weld in their bottom points. Then I got to walk out to the end of the crane and rig the spreader bar. That should be fun.
It's understood that Adam has a strange idea of fun. The job itself is simple enough: to secure a sling over the very end of the boom.
Well, that's it. We're fully rigged up here. I'm going to go down below.
Grant goes up to attach the spreader bar to the sling. Getting this right is probably the most crucial part of the setup.
Okay, Doc, I'm going to let it go.
It looks good.
Down in the dock, Tori welds 2 sturdy steel tabs to the trench plates. Adam fastens the wires, then fantasizes about being the fall guy.
So, right now I want you to picture me as an experimental skydiver. I'm a wetsuit filled with dental alginate, and I am being reverse slingshotted into the ground using these guide wires to guide me, falling all the way into, bang, our seesaw, and hopefully sending our little girl flying.
Casey, you made it.
With impeccable timing, Casey arrives with a bag full of bungee.
Whoa! Look at the size of it!
Oh my God, that's crazy. So the first thing that goes on the big hook is this. It's a dynamometer, and this tells us exactly how much force there is in the system.
The dynamometer gets hooked up to the quick release. Now, all we need is a body, but they're not prepared to risk Carrie's alginate man on a dry run.
So, for our calibration test, we're going to use this, which is an inner tube filled with sand. And the idea is that it weighs 171 pounds, which is exactly the same as our human analog will be.
You know you have a good myth when you're excited about the calibration tests.
Even in testing, this is the myth that keeps on giving.
All right, we're at 2240 pounds of force. We're ready to test this.
Okay, this is calibration test number 1. Here we go. 3, 2, 1.
Wow! Oh my God! Did you see what happened?
Yeah,
we just ripped the inner tube.
Oh, yeah! Crazy. It kind of worked. I mean, if this had stayed together, it would have been perfect.
Yeah, I mean, the bungee cord worked. Our guide wires worked.
The inner tube is going to need a little bit of revision.
Yeah, because this is not an accurate test. If this isn't 171 pounds.
The best possible solution is simple and cheap.
I think what we're going to do is take a duffel bag, wrap it with ties, and hopefully that will keep the weight together so we can get an accurate test.
So, slight change of plan. Instead of an inner tube, we're sending our luggage. Pull in safety.
If the bag holds together, they'll get a precise fix on the speed of the falling skydiver. And they're hoping that's very close to 122 miles per hour.
Calibration test number 2. In 3, 2, 1.
I had a feeling that was going to happen. It just ripped through the straps.
All right.
We're going to have to redo it. So we just did our second test. This time the straps on the bag broke. So the bag didn't even get pulled down. It just fell down.
Worse still, the bungee cord took a serious hit on the carpet-covered trench plates.
This doesn't look good.
Hey, Casey?
Casey has the spare parts to build one more cord, which they'd all like to save for tomorrow. Still, they can't proceed without dialing in the speed, so it's well worth a parting shot. This last calibration test just has to work.
Go, hit it.
Okay, here we go! Yeah! Yeah!
It worked. Hit the target. The bungee didn't break.
That's perfect.
Now we just got to see what our speed was.
To calculate the speed, they carefully check the high-speed replay, frame by frame. And there's reason to be hopeful. The bungee held, and the bag fell unimpeded. Grant does the math, and Tori makes the big announcement.
This bungee cord is done. We can't use it again. We're going to have to build a new one when we do the final test. But the good news is we got a calibration for the speed of our falling skydiver, and it's exactly 122 miles an hour. We are gold.
Still to come.
Oh my God, this is better than Christmas.
This whole crazy myth gets launched sky high and inevitably comes crashing down.
Grand Tori, come on down!
It's the last day of testing the Seesaw Saga, and Jamie's ready to show off his baby.
3, 2, 1. Ta-da!
Wow! Oh my God, this is better than Christmas.
I've never seen a seesaw like this before.
I was expecting a giant piece of steel. This is beautiful. It's elegant. It's gorgeous.
Carrie's diver dad makes a rock star entrance to the dry dock. That's assuming the rock star is Keith Richards. And Jamie's found a way to improve the energy transfer by padding the impact zone with foam.
So what we're doing is slowing that delivery of energy down because it's got to crush this before it gets to the seesaw. This is kind of like the difference between a sledgehammer and a rubber hammer.
Tori delivers the victim.
You're gonna be fine. Your dad Buster's done it millions of times.
And Grant pulls out the shock watches. These stick-on patches measure the force of impact.
If the red one triggers, she's dead. If the green one triggers, she's injured and alive, but she's not walking away.
So they're finally all set to see if a plummeting man landing perfectly on the end of a seesaw could really launch a 6-year-old 70 feet high.
There's no question in my mind that there's enough energy in the parachutist as he comes down to throw that little girl way, way up in the air. And there's a host of problems that we could have. The dummy could just split apart and only deliver part of his energy. Things could not line up properly. The rig could break. And not to mention, she has to go up pretty much straight up in the air for this to work.
Seesaw Saga, full-size test. Grant, take it away.
Here we go. In 3, 2, 1.
Did you expect that? It didn't go up. It shot across the dry dock.
Wow. That was cool. The skydiver hit the seesaw stayed together, and the little girl got launched over 55 feet in the air. That's above the dry dock. Dude, the skydiver exploded.
One word for this. Splat.
Looks like he landed butt first. His legs missed the seesaw, but his upper torso hit it. It's probably about 60–70% of his mass contacted it. And even that amount was enough to catapult her 5 stories up in the air and 70 feet laterally.
Grant checks the shock watches, and the news is grim.
Oh, red shock watch is tripped.
Hardly surprising when the doll was flung high and wide into solid concrete. But this testing needs more finessing.
At this point, it looks like our understanding of the physics is correct. The only problem that we have is our aim of the skydiver at the target.
Little more than half the weight hit the seesaw. With Dan's demise, the inner tube gets a recall. Hopefully, it will hold together.
Now, it is the same exact weight as the average man, but this time we're hoping that we'll impart all of its energy onto the seesaw and fling the girl the 7 stories that we talked about in the myth.
Here we go! In 3, 2, 1!
Didn't see that one coming.
Yeah.
Dang it.
Very painful.
She got clothesline.
Got good deployment of the sandbag, hit the seesaw, the girl went up, but she got tangled in the wires.
She's traveling on a much greater arc than I saw in any of my scale tests, and I think that's because our seesaw's play is much greater than the playground seesaw.
Well, you can see the red grease going up her shoe. That's right where she actually hit the guide wire. So we're gonna have to reset and do this one again.
In the best Mythbusters tradition, the fast-setting winter sun means this next attempt is absolutely our last one. It's now or never. Let's go up.
They can only cross their fingers and hope that this time the girl misses the guide wire.
Here we go! 3, 2, 1!
Well, Jamie said it would work. The skydiver Simulate did hit 122 miles per hour. And despite the colossal sideways arc, little Ariel flew way higher than anyone dared to hope.
She flies about level with our spreader bar, and that's 130 feet.
That's 13 stories, and that was with an angle like this. If we'd got her to go straight up, she would have cleared 200 easy.
This myth sounded totally improbable from the get-go, but Jamie and Adam kept the faith.
The fact is, normally when we're testing myths that have to do with broad guesses about physics, they're usually grossly overestimating what's possible. And in this case, we've come across a myth where the physics are grossly underestimated.
If you had an impossibly strong seesaw, if you had a parachutist that didn't just go splat when he hit it, you'd be capable of launching a little girl up at least 13 stories in the air.
So, how do we call it? Well, sad to say, it's busted. Jamie built the best possible seesaw and almost doubled the 7-story flight. But that little girl would be just as dead as the skydiver.
So I've reviewed the high-speed footage, and I've calculated that the little girl was subjected to 42 Gs, which means, well, she was likely injured just from her launch from the seesaw. Her landing, that's a whole other thing.
Oh my God, that's how far she went?
Nice work.
1 at 7 stories, I think she delivers.
High fives.
I think our work here is done. Oh, you remember the thing we did with the thing?
Yup.
What are you guys doing?
Remember that thing we did with the thing, but it never actually made it to the show?
Uh-huh.
Well, it's on the web.
That's right. If you want to check it out, go to discovery.com/Mythbusters and see what we're talking about.
You two need help.
That's what my psychiatrist said.
Oh, play it again.